Well, we have another question here that says 7xy negative 11 is an arithmetic sequence. Determine the value of x and y. Okay, that's question 2.1. I write the question over here, 2.1. So we have like 7x, y, and negative 11, etc. Now, the question says that it is an arithmetic sequence. So we need to find the value of x and y. There are some properties for arithmetic sequence, you know. The property says that the constant differences, the property says that arithmetic sequence has constant difference. So, in other words, if you have like 7, actually x minus 7 is equal to y minus x, and it is equal to negative 11 minus y. They're all equal. Okay. What else can we do here then? So we cannot really solve this because over here we have like if I try to equate this and that, I won't really find the correct answer because I have an equation with one equation with 2 unknowns, so we cannot solve neither if I use this or that. So I will have like 2 unknowns, so I cannot really solve this equation. But now what can I do? Is that around another way around this? Now let's see. Tn, we know that Tn is given by a plus n minus 1 times t. Okay, this is for arithmetic sequence. So if I say to myself, the first term here, okay, the first term here is T1, which is A. T1 is A, is just equal to 7. Now, these are like T1, T2, T3, and then that T4. Now I can say, okay, so if I need to work out T4, okay, following the formula that you have there, it's going to be as up T4 will be equal to 4 minus 1 here, okay? And then we know that T4 is just 11, so that's 11, actually negative 11. And this will be negative 11 equal to 7 plus 3D. I have this, okay? And then I can work out D here if I move the 7 over. So this will be negative 11 minus 7 equal to 3D. Okay, and that makes 3D equal to negative 18. So to find the value of these, I can just divide both sides by 3. Okay, and then D will be equal to negative 6. That's the constant difference. Now that I got the value of D, I can excuse me, find the value of x, because this means the difference here are just equal to negative 6. All of them are equal to negative 6. So I can say x minus 7 will be equal to negative 6, the constant difference. Okay. So now if I move the negative 7 over, it becomes positive 7 here, I will get x equal to 1. So that's the value of x. I can also work out the value of y by subbing also. I can consider this one or that one, or the last, let's just take the last one. Negative 11 minus y equals to negative 6 also. If I move negative 11 over, it will be negative y will be equal to negative 6 plus 11. That makes negative y will be equal to 5. Therefore, y will be equal to negative 5. So we got the value of x and y. Thank you. The following question is question 2.2. Over here, the question says that given the quadratic number pattern negative 3, 6, 27, 60, determine the general term of the pattern in the form Tn equal to an squared plus bn plus c. Well, let me just move my put this way. Question 2.2. So the numbers were 3, 6, 27, and 60. Okay. And now they say this is a quadratic pattern. That's what the question says. But here, they say that given the quadratic number pattern, now we want to find Cn, the general form of Cn. Okay. We are looking for Cn. And then we know that Cn is for quadratic pattern is just an squared plus bn plus c. Now the value of a is just the second difference over 2. Okay. And then the value of we can also say 3a plus b equal to the difference between the second and the first term, and then also a plus b plus c are just equal to term 1. Now let's move it this way. Let's see. So now I can work out the first difference here and there and there, and then it's gonna be like 6 minus 3, which is 9, positive 9, and then 27 minus 6 is 21, and then 60 minus 27, this is equal to 33. Now if we work out again the difference between these two, 21 minus 9 is just 12, and that's also 12. You see, the difference the second difference is constant, so we can say a will be equal to 12 over 2, therefore a equal to 6. And then over here we can just say 3a plus b equal to the first difference. Okay, t2 minus t1, t2 minus t2 is t2 minus t1 just like that the first difference is 9, because this is t1, that's t2, so t2 minus t1 equal to 9. We sub 9 there, and then here the value of a is 6, so this will be 18 plus b equal 9, and then that makes b will be equal to -9, because if you move 18 over, 9 minus 18 is -9. And then to find a plus b plus c here will be equal to, so a, the value of a is 6, and then b is -9, and then plus c equal to term 1 is just -3, and that will be -3 plus c equal to -3. That means that c will be equal to 0. So then we can work out we can say, okay, that's 0. Therefore, we can say, therefore, Cn will be equal to 6n squared minus 9n. That's Tn. Well, the other question is question 2.2.2. Point 2, the question says calculate the value of the 50th term of the pattern. So this is just a simple substitution. So I'm gonna move here. 2.2.2. So calculate, we need to calculate T50. So in this situation, I'm just going to substitute 50 wherever I have n. Okay, it's going to be 6n squared minus 9. Okay, 50 there. So this will be T50 will be equal to 50 squared is 2500. So it's gonna be like 6 times. Okay, I just need, we can just put it in the calculator, okay? Let's use the calculator for that. So we have like 6 open bracket 50 to the power of 2, and then minus 9 open bracket 50, and that's equal to 14,550, 14,550. So 14,500 and 550. Yeah, that's what it is. And then now the following question is question 2.3. Question 2.2.3. What the question says, let's see. It says that show that the sum of the first n to n differences of this pattern can be given by Sn equal to 6n squared plus 3n. Okay, show that the sum of the first difference of the first pattern can be given by Sn equal to excuse me, n squared plus 3n. Now, let's see, I'm gonna write here 2.2.3. So we excuse me, over here we just need to prove that Sn of the first pattern is equal to 6n squared plus 3n. But now how can we do that? Now they say Sn is the sum of the first difference. Okay, so 9 plus 21 plus 12 plus 33. Here it's like 9 plus 21 plus 33 plus 83. And then the formula for this is given by Sn equal to n over 2 open square bracket 2a plus n minus 1 times d close bracket. Now this will be Sn will be equal to 6n, actually n over 2 open square brackets 2a, the first term is 9, okay, plus n minus 1 times the difference. The difference here is 12, the constant difference. So Sn will be equal to n over 2, that makes 18, plus 12n minus 12, and that makes n over 2, 12n minus 6. Now, Sn will be equal to n over 2 times 12n minus n over 2 times 6. And then Sn will be equal to 6n squared minus, oops, not minus, here, plus. Yeah, plus 3n. And then that's proven. Yeah, excuse me. So thank you.